And hello, so welcome back to OneClass. Again, my name is Joey. I'm going to be your Chemistry 12. This is SCH for you for the Ontario curriculum. This is grade 12 university level chemistry, but these concepts can also be applied to college chemistry and, of course, the AP chemistry as well. Again, my name is Joey. Just a little bit about myself. Again, currently a teacher candidate at York University, so hopefully being specialized in the intermediate senior division very shortly in the next coming months. My main teachables are chemistry, so again, general science and music, but I'm hoping to also get my math teachable further down the road. So again, just a little bit about OneClass. So at OneClass, what we're here is we're dedicated to providing online lessons, so free videos for you and live streams for you, as well for you viewers at home, whether it be parents, guardians, that are showing it to your kids at home or some students that are tuning in from worldwide, internationally. I just welcome you to my channel and my the OneClass channel here, and yeah, just that's just a little bit about myself. So we're gonna get right into it. We started with grade 12 chemistry last week when we talked about organic chemistry. So remember, we're in our first unit here, and we're just gonna build upon that knowledge. So let's just get started. So we'll just review of last week. What did we do last week? So let's look at our kind of notes here. So last week we talked about functional groups. We talked about, we didn't go specifically towards all these functional groups here, but we talked about three main ones. Our main ones here were alkanes, alkenes, and alkynes. We have all of these ones that are being that we have here. All of these ones we have. So we've learned about alkanes with the carbon single bonded carbons, the alkenes with this carbon double bonded carbons, and the alkynes which have a carbon triple bonded with another carbon. And we talked about organic compounds and what's the difference between organic and inorganic compounds. So organic compounds, we have it's built and based off carbon. And then our inorganic compounds are based off substances that are not carbon, basically. So again, with carbon, there's many ways you can bond carbon to carbon and to bond it to other electronegative atoms, such as oxygen, nitrogen. You can there's all sorts of kind of different shapes and sizes when we talk about these ones as well. So last week we talked about hydrocarbons. So again, alkanes, alkenes, alkynes, we talked about the chemical formula and their structure in terms of the structural diagrams and the line diagrams, right? So a little review here. Remember alkanes, for example, if we have this molecule here, CH4H, that'd be H10. What we have here is what we have here is if N equals 4 in this case, and what would this be? So if N equals 4, and we look at our general formulas, which is 2N plus 2, or 2N, or 2N minus 2, we're going to realize that 10 equals 2N. This would be 2, sorry, give me a second. So we're going to realize that this follows the alkane formula, right? Because we have 2N plus 2 equals 10, and if 2 times 4 plus 2 equals 10, with 8 plus 2 equals 10, which is 10 equals 10. So that's good, which means that this is officially an alkane, right? And what kind of alkane is this? We talked about briefly naming, and if we go back to our little chart here for naming, this is C4H10, this is butane, right? And we're going to do a lot of naming today, so just get ready for that. So this is alkane, and then specifically this is a butane, right? So in our structural diagram, what we can write is you can write C, bond C, bond C, bond C. Remember, they are all single bonded carbons. And what we could do is we could add our hydrogens, saturate them, right? So this one would have 3 hydrogens. This one's going to bond to 2 hydrogens here. This one's 2 as well. And this last one will be 3. And we can count we can count these, right? We have, this is carbon 1, 2, 3, and 4. So we know it's butane. So it's N equals NH4, which is good. And then for hydrogen, I'll do it in red. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's going to match up with this number. So it's going to be C4H10. So that's going to be our structural diagram. We talked about also these line diagrams, or you can write them as this, right? This here is our butane line diagram. We talked about this line diagram here. Sorry, line diagram, and this would be our structural diagram. So this stuff is all review, right? And what we can do is remember these hydrogens are are implied that it's bonded to 3 hydrogens here, and then 2 here, and 2 here, and 3 here, right? So again, this is all implied. Sorry, this is a 2 here, not 3. So this is all implied, right? And we usually use line diagrams here, but I'm going to just try to use more line diagrams as we progress onto organic chemistry. Again, there's also so this is an example of an alkane. We have alkenes and alkynes as well. And I don't know if I did an example of alkynes, so I'll do one of those ones really quickly. What about, let's do pent 3 ine. How would you draw that, or how would you do that? So let's break this down. So we have here pent. What would pent be? Pent here, if we scroll down, are the prefix pent means that there's 5 carbons, right? So let's do 5 carbons. So I'm going to draw it out in, I'll draw it in black, I guess, but I'm going to do a line diagram for this one. So it's 1, 2, 3, 4, 5. Remember, each point is 1 carbon, right? But if you look at this is pentane, this is not ine yet. And if you look at our ending here with a Y and E, in this case, this is an alkyne. So we have a carbon triple bonded to a carbon. And where is that alkyne located? It's located at carbon 3. So what I can do is I have to change this this diagram, right? So from 1, 2, and 3, I need a triple bond at 3, right? So I'm going to draw 1. I'm going to have to draw, this one would be, I would actually have to draw this the other way. So this is carbon 3, and then what I'm going to have to do is draw one of these triple bonds this way. So it's carbon 3. Let me erase this for you. Just because the properties of an alkyne, they're always linear, right? This is a linear shape. So that's why I would never get something that's like this or something like that. I would never get something like that. That doesn't exist. It's how you geometrically draw this as well. So it's 1, 2, 3, 4, and 5 would be my pent 3 ine, and I can verify that it is, right? This is carbon 1, 2. We have a carbon here, 3, 4, and 5. And this is pent 3 ine. And if I do the formula, pent, it's C5 first of all. And the H, how many hydrogens do we have? We can simply follow this formula here. It's simply just CnH2n minus 3, right? So 2 times 5 minus 2, 10 minus 2 is 8, right? So this is C5H8. So that's an example of a triple bond. So let's just review of last time. Again, we did cyclic hydrocarbons as well. So cyclohexane, cyclopentane, and whatnot as well. And we can actually add double bonds to our cyclic structures. So something we could actually get something like this. So let me show you really quickly what we got here. In cyclic hydrocarbons, we could get a double bond within a cyclic hydrocarbon, right? So now we're getting kind of fancy here. So we have a cyclohexane. This is simply cyclohexane. And how do we know it's cyclohexane? Again, it's a hexagon, so we have this. There's 6 carbons here. 1, 2, 3, 4, 5, and 6. And it's all single bonds so there's an ane ending here. And obviously it's a cyclo here, right? It's a cyclic structure. So we have cyclohexane. That's how we know that. But what if we had something like this? We have a double bond here. Or sorry, I drew that really poorly. What if we have a double bond here? What would this be? It would still be a hexane, right? We still have 6, right? So this is hex. But then we have, our ending is not A and E anymore. It's E and E, right? This is an alkene, right? This here is a double bond, right? A double bond here. This is a double bond, which means we have an E and E ending, right? Hexene. And it's still a cyclic structure, so I can still write cyclo here. So it's cyclohexene. And if I want to be really specific, when I'm counting the carbons, I wouldn't actually start counting my carbons from the top of the hexagon. I would actually start counting in where the double bond starts, because that's where the priority is. We'll talk about priority more when we talk about naming, but we always want to start with we want to minimize the number where our functional groups are, where the location of our functional groups are. In this case, it's at our alkene, so that's our functional group. So we want 1, 2, 3, 4, 5, 6, and that's how we would label this one. So this would be cyclo hex. You can say hex 1-ene because to indicate the location of our double bond, or you can write cyclohexene because the one is implied here in this case. But I would accept. I like cyclohexene personally, just because it gives a bit more detail as to where the double bond lies in the cyclic structure. So that's what we did and we did a lot of isomers as well. So structural isomers, geometric isomers, and stereoisomers. That's what we did last week. And today we're going to move on to types of carbon atoms and molecules. So we're talking about primary, secondary, tertiary, and quaternary carbons. And this is actually a very, very easy concept here. And I'm going to use a structural diagram here. So I'm going to actually copy the structural diagram, and I will show you the different types of carbon atoms. Sorry, this is CH3, this is CH3, and this is a CH3, CH2, CH3. In this case, this is a condensed structural diagram because what I could always break this down to C and then bond H, bond H, bond H, but I'm just gonna write CH3 for plain sake. So this is a condensed structural diagram. That's the condensed structural diagram, where basically the hydrogens have are kind of, we don't draw the bonds, but we just say CH3 or something like that, so we know it's this carbon bond to 3 hydrogen molecules. So in this case, how do we figure out which one's a primary carbon or a secondary or tertiary or quaternary? So let's start with primary. Primary it defines as one carbon atom that's attached to only one other carbon atom. So in this structure, which one would be our primary carbon? We have so many options. We have 1, 2, 3, 4, 5, 6, 7. We have 7 options to choose from. Which one would be my primary carbon? So in this case, this guy would be my primary carbon here. This here, 1. Sorry, I'm going to use this actually I'll do this in blue. This carbon here is a primary carbon. And why do we denote with a 1 and a little circle on top, and why? This carbon atom is attached to one other carbon atom. So it's only attached to, oh no, actually this is not a primary carbon. Sorry, my bad. This is not a primary carbon. Actually, I don't think we have any primary carbons in this case. Okay, so if I redraw this as 1, 2, 3, I have a methyl here of 1, 2, 3. This is a OH, and then this here is sorry, give me a second. I'm just transferring this to a structural one. Sorry. Oh, this is no whack. 1, 2. This one would be 1 and 1. That's how I would draw this one here. This carbon is actually this is not a this here is actually, no, this is a primary. What am I saying? It's just harder for me to visualize it here, but this is a primary carbon because it's a carbon that's attached to only one other carbon. This here is bonded to this carbon only. So this here is a primary carbon in this case. What about what other carbons are there? There's secondary, tertiary, quaternary, right? So in this case, what we have here is, in this case, they were nice and they give us that this is a tertiary carbon. And the reason why here is that this carbon, we're talking about this one now, is bonded to 1, 2, and 3 carbons, which means this here is a tertiary carbon. It's bonded to 3 other carbon atoms. Same, and then with this one here, this carbon here, so this guy here is bonded to 1, 2, 3, 4 carbons. So this one here is a quaternary carbon. And then all of these ones are this one, and this one here. These two here are simply just primaries, and then this one here is a primary, and this one here, we have this specific one here is bonded to 1 and 2, right? So this one here is a secondary, and this one here is a primary. Again, it's just whatever. How we talk about carbon atoms is simply just carbon bonded to how many other carbons. So for example, this is a primary, and then this would become a secondary. This would become a tertiary. This one here is now a quaternary, right? So again, it's bonded to how many other carbons. This is a 1. So that's that concept here. So when we talk about primary, secondary, tertiary, and quaternary carbons, you're going to be able to follow along as to what I mean by that. So again, we have primary. So one, we have primary, secondary, tertiary, and we have quaternary. So again, 1, 2, 3, and 4. Sorry, this O was bad. That's what we have here. So that's that concept. So we're good for that one. And then let's look at some physical properties of hydrocarbons. So let's talk, when we talk about physical properties, what do we mean by physical properties? So if we think back to grade 11, physical properties, melting point, boiling point, solubility, all of these come back in grade 12. So, so that's what these are. In physical properties, when we're talking about physical properties, it's mostly, we're talking about electronegativity. So we're talking about solubility and whatnot. So again, physical properties of hydrocarbons. So let's say, let's talk about alkanes. Specifically, these are alkanes. So alkanes are non-polar. So again, because hydrogen and carbon are relatively similar electronegativities, right? So if you look at our, let me just Google electronegativity chart here. Electronegativity periodic table. So let's do that, and then we can I can actually tell you what it means by that. So can I zoom this in? The numbers are really, really small, so maybe not this one. Electronegativity periodic table. Maybe this one. This one's a lot better. So you can see it on my screen here. If I look at hydrogen is 2.1 in this case, carbon here is 2.5. If I subtract both of these electronegativity numbers, I only get 0.4, which means the substance is non-polar, right? Remember, I'm looking at this. Alkanes have, it's a C bond C, so that's 2.5 minus 2.4, which means delta En, electronegativity is 0. C carbon bonded hydrogen, delta, the change in electronegativity is 2.4 minus 2.1, which is simply just 0.3. So both of these ones, therefore, it's nonpolar, right? Therefore, it's nonpolar. Polar substances or molecules or whatever you want to say. So when we talk about nonpolar substances, what is it? What's its solubility, right? So because we know it's nonpolar, therefore I'm going to underline this. This is important. Therefore, nonpolar. How does this affect solubility? Well, when we talk about solubility, remember, like dissolves like, right? Remember, back to grade 11. So polar substances dissolve in polar solvents, and nonpolar substances dissolve in nonpolar solvents. Sorry. So in this case, solubility. So it'd be low in polar solvents, and it would be, I guess, high in nonpolar solvent. So when we talk about polar solvents, it's something like water. Water is polar, right? H2O. And when we talk about nonpolar solvents, we're actually talking about like hexane, or like DMSO is another one, and whatnot. So again, a lot of these ones are nonpolar solvents. So actually, hexane is actually a solvent. And we actually all use hexane as a nonpolar solvent in organic chemistry. So that's solubility, and let's talk about nonpolar compounds, and let's talk about intermolecular forces. That's a good one as well. Let's talk about intermolecular forces. This in red. This is an important topic, and we'll talk about more about intermolecular forces. But you did some of them in grade 11. Intermolecular forces. In this case, because it's nonpolar, we don't have a polar dipole. So we have no, first of all, no hydrogen bonding, or no H bonding. No H bonding because we don't have hydrogen with fluorine or with nitrogen or oxygen, so no hydrogen bonding. We don't have any dipoles because we don't have electronegativity difference, so no dipoles. So no dipole. No dipoles. So what are we left with? We have, all we're left with is London dispersion. So the only thing we have here is London dispersion. And what that is again, London dispersion, just it's the weak intermolecular forces that hold the molecules together, right? So the bigger the compound, the higher the London dispersion, right? So in this case, we have and we have here just London dispersion forces that exist in alkanes. Remember, we're still talking about alkanes in this case. So we just have London dispersion forces, and let's look at boiling points now. If we look at boiling points, look at the trend. So if we have methane, we have negative 161 degrees Celsius. So again, very, very, very low boiling point. If we all go the way up to octane, for example, at 125, so it boils at 125, so it's much, much higher. So again, so how does that affect boiling point? So I'm going to do some blue. London dispersion forces affect boiling point because the bigger the compound, or the larger the alkane, longer chain alkanes means that it's higher. I'm going to say LD forces, right? So if it's higher LD forces, then we have a higher boiling point, right? Higher BP, right? And that makes sense, right? When we look at the chart, this makes sense. It creates more opportunities for intermolecular interactions to hold the molecule together. So let's compare, and then we used our example of methane. Actually, I'll do this in black because this is not as important, because this is just an example. We talked about methane CH4 versus octane, which is C8H18, right? So very, very, very different molecules here. As you can see, 8 carbons, more opportunities for intermolecular forces to hold, which means higher boiling point in this case. So, and boiling point, it works for melting point as well. So higher boiling point, higher melting point as well. So these two things also exist. So this is also higher melting point. And we can actually Google this, right? So if I say, I can do melting points of first 10 alkanes or something like that. And what we know here, or what we can tell here, it follows the exact same trend, right? If you look at if we look at the melting point, look, it also increases as we increase our size here, right? So again, it's the same. It follows the same trend as our melting point because it has higher London dispersion forces, or greater. So higher MP and higher BP and higher MP as well. Higher boiling point and melting point. So again, these are all physical properties of hydrocarbons. We could talk about isomers and isomerization and how it affects boiling points, but you don't have to worry about that till maybe, I think it's second year organic chemistry. But basically the difference is the geometry of the isomers also make for slight variations in boiling points, and it's just because how it binds together, and the geometry of how the molecule is constructed is different. So don't worry about that. So this is so now we're going to talk about nomenclature, and that's like the really, really big part of organic chemistry. So I'm going to do this in red. So nomenclature is huge. And what does nomenclature mean? So this nomenclature. So nomenclature means, what we're doing is we're simply just naming compounds. So we've actually done a lot of naming already in the past. You know how to name ionic compounds, covalent compounds, multivalent compounds, polyatomic compounds. You know how to name these already from grade 11. So for nomenclature in organic chemistry sense is we follow different rules, and we follow this something called IUPAC rules. And what it is kind of like an international. I don't actually know what IUPAC stands for, so I'm going to actually Google this. But IUPAC basically is an international kind of regulation to standardize naming. So it's an international union of pure and applied chemistry. Wow, today I learned. But this is an IUPAC rules, and we use that to kind of normalize naming throughout across the country. So scientists from Germany can talk about same chemical compounds as scientists in Canada, for example, or in the States. So we use IUPAC rules. And basically, this is a very, very good chart to memorize. I'm not going to draw it here, but you can find this literally anywhere. Again, where you have different prefixes, and we talked about prefixes a little bit before, for different number of carbons. So again, meth is 1, F is 2, prop is 3, but is 4, and then 5, and then so on. So this is a very, very good good thing to memorize. And how I memorize this is from pent to dec. So how I memorize, and this is a little thing here. A trick or a little hint from pentane, I'll just write pent to dec. You can think of shapes. Think of shapes. So we have pent here is a pentagon. There's 5 sides to a pentagon. Hex is hexagon, heptagon, octagon, nonagon, decagon, right? These are all shapes. So that's what I think of. So basically what I'm actually memorizing is just these 4. Methane, ethane, propane, and butane. And these 4 I encourage you to memorize as well. So meth is 1, F is 2, prop is 3, and but is 4. And I'll do that in blue. So what we have to actually memorize is meth, which is 1, F is 2, prop is 3, and but here is 4. So again, just these 4 ones are ideally what you have to memorize, because the trick from pentagon to decagon, you know how many sides there are. Sweet. So that's a bit of nomenclature. And again, these rules apply. When we talk about nomenclature, the rules are cumulative, so they stack upon each other. So I'll let you know when we talk about drawing and when we talk about naming how these rules apply. So let's do some branched alkanes here. So branched alkanes is something like this. So hydrocarbons can form branches where smaller hydrocarbon chains stem from the parent chain. So these are called alkyl groups. So alkyl groups. So they're basically just branches from the main chain. Branches from main, I'm going to write here, hydrocarbon chain. And what that is I'll show you what that is. So for example, if I have a butane like this is 1, 2, 3, 4, we know this is a butane. And what if I stick a little meth, or what if I stick a line here? How would I name this compound? So again, we use the exact same rules, right? So we'll talk about naming actually first. We'll talk about naming a little bit before, but I just want to introduce you to this concept of alkyl groups first. So what we do is we have here we are actually, let me go through the names first before I go. I'll jump back into branched alkanes. But how do we name branched alkanes? So how do we name this compound? So we follow these rules, right? So first, step 1 says identify the longest carbon chain. It may travel through 1 or 2 branches. So in this case, the carbon chain is the longest chain would be, and we label from like left to right, or sometimes right to left, depending on how which one's longer. So for example, this is 1, 2, 3, and 4, right? So this is my longest branch in this case, and we have to number the carbon starting from with the end closest to the branch. So this is 1, 2, 3, 4. You could label it as 1, 2, 3, and 4, but it doesn't change anything in terms of the geometry or the naming, so you don't have to worry about that. And then what you're going to have to do is name each branch and identify each location on the parent chain by the number of the carbons. So these rules are like very, very formal. How I like to do it is first I number the carbon chain, and then I go back to, okay, what is the prefix for 4? The prefix for 4 here is but, right? So in this case, it's but. So we have BUT, so that's our first thing, that's our parent, the prefix. And is there single bonds, double bonds, triple bonds? What is there? There's only single bonds, right? So only single bonds here is ANE, right? So Bob Smith writes, I recommend to put topic in title. So I actually don't have access to the website. It's just this chemistry 12, but I actually put a little little titles where my notes are. But today we're just doing the organic chemistry unit for that. So I don't have access to changing the actual website. But maybe that's something that I can recommend to whoever's running the website design to maybe change this chemistry 12 to something a little bit more specific, maybe something in brackets or something like that. But thanks for the recommendation. So again, we have butane because we have single bonded carbons here. And what else do we have? We have this little branch that sticks out from 2, right? I'll do this in red. We have a branch that sticks out from 2. You see here that this branch, there's 2 here. There's a 1 carbon that sticks out from 2, right? So when we say there's 1 carbon, let's check our prefixes. 1 carbon here is meth, right? So meth here is our alkane, and because it's an alkyl group, it's a branch that's forming from the main hydrocarbon chain. Remember, this blue one here is my main chain, right? This here is my main chain here, and this red one is it's a side chain. It's a side chain, you know. So it's a side chain. Side chain. So how would we name this? So with side chains, what we do is they're called an alkyl group. So it actually switches. The ending, instead of A and E, we switch it to YL. So it's just like alkyl, right? So this YL, sorry, I'll do this in red. Alkyl, in this case, is a side chain. So in this case, because there's 1, it would be a methyl, right? So it'd be methyl. So in this case, the side chain will be a methyl group. So how would we name this though? Because I know it's butane. So we would label this methyl as, this would be a methyl here. I would write methyl before butane, and then I would have to state the location of this methyl group. In this case, it's located on carbon 2. So I write 2-methyl butane. And this is kind of my IUPAC name. So this is the IUPAC name for this compound here, 2-methyl butane. So we can check, right? We know longest chain here is 1, 2, 3, 4 carbons. So it's but. They're all single bonds, so it's A and E, which is good. And we have a side chain, a methyl group at carbon 2. At carbon 2, I have this 1 carbon, so it's 2-methyl butane. So that's kind of how you name branched alkanes. And we're going to do lots and lots and lots and lots of practice with this, because this is a very, very important skill to have. Because once you have mastered this, all we're doing is we're just adding little extra pieces, little extra functional groups to our IUPAC naming. These are all alkyl groups. Some of them have structural isomers. So again, we have the propyl group and a butyl group are sometimes different. So these are a bit more, they're not technically IUPAC in terms of when we talk about N-propyl or isopropyl. We can simply, but I'll show you what that means. So in a propyl group, we have something like this. So if we have a butyl here, and then if we had something like, if we had something like that. So this group here, this main chain, so again, it's 1, 2, 3, 4, 5. Oh, actually, in this case, it's 1, 2, 3, 4, 5. So it's actually, so because I'm labeling from 1, 2, 3, 4, 5. So it's actually, there's no kind of, there's actually no propyl group in this case. So actually, that's my fault. So maybe I'll extend this chain a little bit to make this the main chain. So maybe I'll do 2 more, something like that. So this is, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, actually, in this case, it won't be a propyl. So maybe I'll just let me just erase this. I'll show you what it means when we have a structural isomer. How about that? It's a bit easier when there's an example for us here. But this is just naming branched alkanes. So what we're going to do is we're going to practice a little bit on this skill, and then we're going to move on to kind of aromatics here. So I'm going to just draw kind of organic compounds, and we can start kind of naming organic compounds. How about that? So let me draw one for you, and I'll give you about 2 minutes or 2 to 3 minutes to figure out what the naming is, and I'm going to search up some practice problems for us as well. So let's do this compound here. So let's do 1, 2. Well, actually, let's do an alkene. Let's do this one. So let's try to label this compound here. I'll give you about 2 minutes. If you're in the chat, I would love for you to kind of maybe walk me through your thought process as how to label this chemical compound in terms of IUPAC. So if you want, you can kind of type out your results or what this is, or give me some pointers as to how would we approach this problem. So I'll give you about 2 minutes to do that while I pull up my organic worksheet for you all. Sorry, just give me a second. I'm trying to find my worksheet that I made. Sweet. Okay, I have this here. Okay, so how do we approach this problem? How will we label this chemical compound? So let's look at, so first thing we have to do, find the longest chain. Where is our longest chain in this case? So we have here, we can start from this branch or from this branch. Let's start from here. So this is, I would do 1, 2, 3, 4, 5. That could work. Could I do 1, 2, 3, 4, 5? Probably actually. So this, if I'm labeling from left to right, it's actually incorrect in this case. And why is it incorrect? If I label from left to right, remember I have to put priority on this double bond, right? I care about this double bond a lot. It's a part of my functional groups. So I want to make this double bond the lowest number. So in this case, I would not label from left to right. I would do from right to left. So if you did, for viewers at home, if you did a 1, 2, 3, 4, 5, that's also incorrect. Just because I have to, again, make this double bond my my lowest number in this case. So in that case, I will have to do from right to left. So let's do that. So from right to left would be 1, 2, 3, 4, and then I could pick either one for 5, and this doesn't really matter. So in this case, it doesn't matter. So I'm gonna just put 5 here. So now this is the correct numbering for this is the correct numbering for our carbons, because this travels through the longest chain and it puts priority on this double bond here. So this is correct. So I hope you have this at home. So 1, 2, 3, 4, 5. And if we have 5 here, what is our prefix? Our prefix would be pent, right? We have P-E-N-T as our prefix. We have pent, and do we have a single bonds or double bonds or triple bonds? We have a double bond here, right? So this is a E-N-E ending. So pentene, right? And we have to be a bit more specific than pentene. Where is the location of our double bond? The location of our double bond is on carbon 2, right? On carbon 2, we have this double bond here. So in this case, it's not pentene. It would be pent-2-ene. And why do we do that? We put the 2 here to state that this is the location of where the double bond is, and ENE is where so 2 represents the location, ENE represents the double bond. Pent represents the main chain. So are we done yet? We are not done yet, because we have, remember, this here is our main chain. Main chain. What's left here, the red, we have the side chain, right? So again, this is just a 1 carbon side chain, which means this is a methyl group, which is awesome. And where is our methyl group located? It's located on carbon 4. So I can simply just write 4 here, dash, and then put methyl. And here is our IUPAC name. This is 4-methyl-pent-2-ene, right? And we could double check that because we have 5 as our longest chain. 2 is the location of our something. ENE is our double bond, so location of the double bond. This methyl here represents this methyl at carbon 4. So 4-methyl-pent-2-ene will be the correct answer for this compound here. So let's do, I'm gonna come up with one more question before we do our some practice problems. I have a worksheet to kind of work through. Let's do one with a cyclic group. So let's do this one with maybe with this and then with this. So how would I name this structure? So again, I'll give you about 2 minutes to figure that out, and then we'll work through it together. So I'm just gonna get a drink of water real quick. So again, where is our longest chain? And then how would you number, or how would you label the carbons, is the first 2 things you should ask yourself when you are approaching this problem. So I'm gonna do the main chain in blue. Sorry, yes, I'll do the main chain in blue. So again, identify the longest chain. In this case, it's very, very easy because it's simply the cyclic structure, right? But so this, well, I know we have this is the main chain. So this here, this entire cyclic structure is the main chain. But where do I start at 1? Where is 1 in this case? In this case, I want to place I want to place priority on the branched alkanes, right? So you see here, I have 1, 2, I have a two carbon alkyl group here. So this one will hold priority for it. So this carbon here will be 1, and then I want to go down. I want to go towards the right here to make this the next lowest number. So this would be 2, 3, 4, and 5, and that's the correct carbon labeling for this compound. I want to put this group and this group. I want to minimize those numbers. I want to place importance on those, right? So now we have 2 side chains in this case, right? We have here, if that was our main chain, we have a side chain here, and then a side chain here as well. So let's label first the main chain. So again, with the main chain, what do we have? 5 carbon ring is pent again, so P-E-N-T would be our prefix. And do we have a double bond, triple bond, or single bond, double bond, or triple bond? In this case, it's all single bond, so it's simply just pentane, right? And what we have here is a cyclic structure. It's the shape of a pentagon, so this would be cyclopentane, right? So it'd be, let me make some room actually. So this would be, this here is oh, my Siri went off, sorry. This is cyclopentane. And then we have to take care of our branch groups, right? Our alkyl groups here. So we have on 1, we have how many carbons do we have here? We have, this is carbon 1 and this is carbon 2. So in this case, we have a ethyl group, right? ETH is an eth group, right? And remember, we drop the ane instead of ethane because it's not our main chain, it's ethyl, right? So at carbon 1, we have an ethyl group. So we would write 1 and then dash, and then we write ethyl, right? ETHYL, ethyl. And then on carbon 2, we have this, we just have 1 carbon here, right? So again, 1 is meth. So this would be a methyl group. So this is an ethyl group at 2. And this one is a ethyl group at 1. And this is a methyl group at 2. So it would be 1 ethyl dash, and then you write 2, and then write dash, and then you write methyl to fill this up. So this is 1 ethyl, 2 methyl cyclopentane would be our correct answer for number 1, or sorry, for number 2 here in this case. I also totally forgot to do cis and trans. I just realized in this case, so I'm gonna go back to this question and I'm gonna redo it. I'm gonna do this as well in black. So I totally forgot that. Sorry, because we talked about cis and trans isomers. So if you look at this double bond here, I'm gonna circle this. If you look at this double bond here, is this cis or trans? I'm going from here to here to here. Is my carbon groups, are my carbon groups the same side or the opposite side of our double bond? So in this case, it's one side here and one side here. They're on opposite sides. So in this case, it's a trans group. So I'm gonna have to say, or actually I'll do this in blue, because I don't want to mess up the side chain here. So it was 1, 2 here, right? So here they're on opposite sides. So this is a trans. So actually we have to put trans in front of this entire name here. So this is trans 4-methyl pent-2-ene. I always forget cis and trans, I'm so sorry. But this is trans 4-methyl pent-2-ene would be the correct answer for number 1. And for number 2, this 1-ethyl 2-methyl cyclopentane. So this is number 2. So what we're going to do is I'm going to do a little bit more of some naming stuff, and I'm going to do that. Here. So maybe it's on my Google Drive where me and a friend actually made this organic chemistry quiz. So I'm actually going to reuse this for our exercise for today. So let's do a couple. Maybe let's do 1 and 2 in this case. Actually, 1's quite hard. So let's do number 3, and then we'll go back to number 1 as we get more confident. I'm going to redraw this compound here. So we're doing number 3. Actually, let's do 2 and then 3 and then back to 1. Sorry for the ordering. It's just how because we're looking at this for the first time. I want us to be, because this is a quiz, so I can put kind of anything I want. But for our purposes in one class, I want to kind of stagger our knowledge here. So we're going from easy to hard in this case. So this is CH3, CH, and again, this is a condensed structural diagram we have here. CH bond CH2. Sorry, that H was really bad. CH2, CH2, CH, CH3, CH2, CH2, and then CH3. So how would we label this? What is my longest chain? So let's try to find my longest chain in this case. Want to go from left to right or right to left? So maybe take a minute to think about that, and then we will answer the question. So again, where am I putting number 1? Which one will be my first carbon? Will I label left to right or right to left? So in this case, I would, if I started, let's walk through it. If I started from left to right, I would place maybe this one as 1, 2, 3, 4, 5, 6, 7, 8, right? Or I could start from, I guess, from here and do the exact same thing. But in this case, this would be 1, and then I'll have 2, and as it's actually the same thing. So it doesn't matter if we pick these 2 points, so that's fine. And let me try labeling from left to right. Would this be correct? So if I go from 1, 2, 3, 4, 5, 6, 7, 8, would that be correct? If I labeled from right to left, would actually not be correct. And the reason why is that I want to place some priority on this chain, on this little side chain here, and this side chain here as well. So if I did the right to left numbering in red, I would have this as 4 and this as 7. If I did the blue numbering, this would be 2 and this would be 4. So again, the blue numbering trumps it. So in this case, I would go from left to right. So that's great. So again, this is my main chain here. So my main chain, I'm going to circle this kind of long thing here. This is my main chain. Sorry, my 3 kind of got lost here. This is my main chain, and then my side chains here would be on, this is on carbon 5, and then on carbon 2 I would have a side chain. So how would we name this? So let's follow our rules, right? Let's follow the rules of our main chain first. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 sides to an octagon, right? So OCT. OCT. Are they all? So that's 8 carbons. Are they single bonds, double bonds, or triple bonds? In this case, are only single bonds, right? So it's oct and then just ane at the end. So this is octane. Let me make a little bit more space. So this is octane. So that's great. So sorry, I'm going to do this in blue so it helps you out. This is a main chain would be in blue, and then the side chains would be in red. That's how I would do it. So this is that's blue. Octane. Octane, and then I have to take care of these side groups, right? So I have a side group first. Let's start with the lowest number first. In this case, I have a side group of 2. This is a 1 carbon side group. So this is a methyl group here. So it's at carbon 2. So this is 2 methyl. And then I have another side group here. At carbon 5, I have another methyl group. So at carbon 5, I have another methyl group. So this is my correct answer here is 2 methyl, 5 methyl, octane. And we can check this, right? We have 1, 2, 3, 4, 5, 6, 7, 8 carbons in my longest chain. So oct, and then it's single bonded carbon. So octane. We have a methyl group at 2 and a methyl group at 5. And it's 2 methyl, 5 methyl. So actually that's incorrect actually. So 2 methyl, 5 methyl octane, or what we can do is we can actually rewrite this entire thing. And this is the kind of the new rule that this problem poses. Here we can actually group these methyls together, and how we do that is we simply put. So this is what's our answer before, and we would change this to, this would be 2, 5. So we put the locations together, and then we put dash and we put methyl. But because instead of because we have 2 methyl groups, we are going to put dimethyl. And then we have octane at the end. So what we did that was IUPAC allowed us to group 2 methyl and 5 methyl together to make 2,5-dimethyl. It's just a simpler way to write the structure out. This is 2,5-dimethyl octane. So that's this is for number 2 here. So let's do number 3 and then do number 1. And then that will be our kind of lesson for today. Again, this is just nomenclature of alkanes, alkenes, and alkynes, and some cyclic stuff as well. And we can actually do the reverse and draw them, but I don't know if we have time for that. But let's do question 3, because we didn't really do a triple bond yet. So I'm going to draw. This is 1, 2, 1. Oh, whoops. What did I do? 1, 2, 1, 2. 1, one, and this triple bond here, and then one. Okay, so how would I label this compound? So again, I want to put priority on my triple bond, right? So I want this to be the lowest number. I can't start from here, but what the best I can do is start from this side. So I'm labeling from left to right. So this would be carbon 1, carbon 2. This is 3. Would make this, if this is 3, then we make this 4, and this would be 5, and then either way it doesn't matter, so I'll go up and put 6 in this case. So this is 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 6, which is correct. And remember, this is my main chain. So I'm going to do this in blue. This is my little main chain here. And what are my side chains in this case? I have a side chain at carbon 4 and that carbon 5 as well. So let's do the main chain first. So what is the name of my main chain? Again, I have 1, 2, 3, 4, 5, 6. There's 6 sides to a hexagon, right? So this is a hex. And is there double bond, single bond, double bond, triple bond? I have a triple bond at 2, right? So it's a hex. So triple bond would be ein, so hex ein. But then my location I have to put, right? I have to indicate the location. So this is hex 2 ein, right? So this would be hex 2 and then y and e. And then now we have to do our side chains, right? We have a side chain here. The lowest number here is 4. And then we have another one, 5. So at 4, we have, this is just one carbon, so another methyl group. And at 5, we have another methyl group, right? So what we can do is, remember, we can do that little combination thing. We can put 4, so our locations first. So 4, 5, dash, and then because there's 2 methyl groups, I'm doing dimethyl. So there's 4, 5, dimethyl, hex 2 ein would be our answer for number 3 here. So again, we could check 1, 2, 3, 4, 5, 6. 6 carbons is hex. There's a double bond at 2, so it hex 2 ein. And we have a methyl group at 4 and a methyl group at 5. So it's 4, 5, and then we have to write the di in front of it to indicate the 2 methyl groups in this case. So it's number 1. Number 1 is slightly harder, and I'll show you why that is. And I'll redraw it first, and why I'll show you why it's slightly harder. So we have this one here. So what is our longest chain? So we could start from, let's try from left to right first. So we start from 1, 2, 3, 4, 5, 6, 7. Or we could go from right to left and put 1, 2, 3, 4, 5, 6, 7, right? So again, if for the blue one, I would have my double bond at 2, and I would have a double bond at 6, right? And then for my right to left one, I have a double bond at 1 and a double bond at 5, right? We want to pick the one with the lowest number, so the red one here wins out. So I'm going to erase all these blue ones here. Erase these blue ones, and we're going to label from right from right to left in this case. So that one was a bit tricky when we talk about labeling carbons. And then remember, the blue chain I'm going to put as my main chain here. Sorry. And then the red one will be this is my side chain here. So what would I have in this case? So let's say 7 here. What's 7 sides in a shape would be a heptagon, right? HPT. H-E-P-T, sorry. A heptagon. And do I have a double bond, single bond, or triple bond? Sorry, single bond, double bond, triple bond. In this case, I have 2 double bonds, right? I have one here at 1. I have a double bond at 1 here, and a double bond at 5, right? So in this case, I have hept 1, 5, and then instead of ene, I'm going to put diene. So D-I-E, D-I-E-N-E. Hept 1 for diene. It follows the exact same rules with my methyl groups from before, right? If I had 2 methyl groups, I could put the locations together, put 4 or 5, and put di, and then with the methyl, right? Because there's 2 single methyl alkyl groups. In this case, I can put the same thing, right? 1, 5 means I have 1 and 5. I have 2 double bonds. I have 1 double bond at 1, 1 double bond at 5. So I could put 1, 5, and put ene, and then put a di in front of it, a diene, right? To indicate that there's 2 double bonds there's 1 double bond at 1 and 1 double bond at 5. So that was a little bit confusing. That's why I saved this one for last. So this is hept 1, 5 diene. And that's my main chain. And then my side chain here is I have a 1 carbon, which is a methyl group on 3, right? So this is a 3 methyl. So 3 methyl hept 1,5-diene. Are we done yet? No, we are not, because we forgot to do cis and trans. So let's analyze these double bonds here. So let's analyze this first one here. Does this have a cis or trans component in this case? In this case, it actually doesn't, because what we have here is we have, if I draw the hydrogen, we have 1 hydrogen here, and then we would have 1 hydrogen here and 1 hydrogen here, right? So in this case, the other stuff that we care about is on this side, and it's not on the other sides as well. So in this case, we don't actually have a cis or trans in this double bond, but what about the second, the carbon 5 double bond? Do we have a cis or trans? It looks something like this. It looks something like this, and this is carbon 4, 5, 6, 7. Do we have a cis and trans about the carbon 5 double bond? We do, right? These two sides are on the same side of the side double bond, so this is a cis double bond. So cis isomer, sorry. So we have to put here, this is a cis 3 methyl hept 1,5-diene. A lot of people, what they write is they would write, to even clarify this even more, because this cis can be either the first double bond or the 5th double bond. What we could write is 5 cis or something like that. So 5 and then right, cis 3 methyl hept 1,5-diene. I'm not particularly sure if I should write the 5 here, but maybe in this case I would do it to simplify, to clarify that this cis belongs to this the 5th double bond instead of the first double bond. So I would accept the 5 here. If you just wrote cis, I think I would accept that as well in terms of impact naming. So that's that would be for number that was for number 1. So there's this last exercise, but we actually did a lot of naming today. So maybe I'll do one last one, and I'll kind of breeze through this one as we go. And I'm going to draw a line diagram. I'm going to convert number 4 to a line diagram because I don't really want to draw the carbons out. So it's 1, 2, 3, 4, up. Sorry, 1, 2, 3, up here, the bond here, 1 here, 1 here, 1, 2, 3. So what would this be? So again, I want to put priority on this double bond, right? So I want to label this this double bond as the longest chain. So in this case, it would be, I would have 1, 2, 3, 4, and then 5, 6 or 5, 6. It doesn't matter which way I go, because this would be 5, 6, 5, 6. It doesn't matter. I'm going to choose to go down 5, 6, right? So again, this is my longest chain in this case. And then my side groups, I have two side groups here of 1, 2, or I have 2 side groups that have 2 carbons each, right? So that's my side group. So how would I name this compound? 1, 2, 3, 4, 5, 6 would be a hexagon. So this is a hex. Hex is my prefix. I have a double bond at 2, so it's hex 2-ene. Hex 2-ene would be my main chain. And then for my side chain, what would I have? In this case, I have a 1, 2. I have an ethyl group here. Eth is the prefix for 2, and then it's an alkyl group. I also have an ethyl group here. This is at carbon 4 and at carbon 3, right? So in this case, I could group, because they're the same alkyl groups, I could group this into 2. I can simply say the locations are 3 and 4. So 3, 4, and then dash, and what I could put is, I can put diethyl. So this is 3, 4 diethyl hex 2-ene. And then I have to check for, every time we have double bond, I have to check for cis and trans, right? So I'm going to redraw this double bond. So it went from 1 to here, and then went to here, and then there's the other stuff that goes on after, and there's another one that goes up here. So in this case, we care about the main chain. So this was the main chain, and this is the main chain. They are opposite of the double bond, which means this is a trans isomer. So I'm going to write trans in front of this entire name. So this is trans dash, or you can write a dash or just leave it as a space. I usually just leave it as a space. So this is trans 3, 4 diethyl hex 2-ene would be my final answer for this problem here. So we've worked through all this stuff here. So what did we do today? Again, we did a lot of naming for alkanes, so alkanes, alkenes, alkynes, and cyclic structures. We talked about our properties, so physical properties of alkanes and intermolecular forces as well, how they're nonpolar and they're low solubility in polar solvents, and then we went over some review from last week. So for next week, what we're going to do for next session is that we're going to continue with this one. Instead of just naming, what we're going to do is we're going to do some drawing. We're going to draw these following organic compounds, and then we're going to start adding on to our list with different functional groups. So as always, thank you for watching and have a great day.